The numerical is as such. Consider a series RLC circuit, which is a second order circuit we have seen, because there are two energy storing element. One is inductor and another is a capacitor. So this is our first state variable analysis numerical. So this is the easiest numerical, and many forms are possible. So for the same system, we are going to find that there are different state variable representation possible. So first, let us see, consider a series RLC circuit. Assume that output is the circuit current. So there are two state variables, as I told you. One is shown here as the circuit current. So the same circuit current can be called as ILT or ICT or IRT or I input T or IT. All the things are same because there is only one current present in the system, which is called as IT. And it is a time varying quantity. That is what we have to see. Another state variable is actually VCT. Now here we are supposed to find out the state variable representation. Now you don't have any idea about what is meant by state variable representation for any given system. So let us develop what is the state variable representation for the given system which is having its input as xt. Now this input can be step, ramp, it can be sinusoidal, anything that is immaterial. But this xt quantity will come in the state variable representation. And there are two main state variables. One is called as IT, another is called as VCT. So let us see how to develop the state variable representation for second order RLC circuit. This is a second order system as it is shown here, as there are two energy storing elements L and C. So these two are the memory elements, or they are storing energy, so that is they are remembering something. That's why they are called as energy storing element. Resistance is not called as a energy storing element. There is a linear circuit, that is we have to remember. So whenever there is coming differential equations and all, you should not get confused with differential equation and linearity. Okay, so this is a linear circuit. So these two are, that is L and C, are called as memory element. In this case, we are assuming, so this thing should be given to you, what should be taken as output, or if not given, you can assume any. Okay, so for the first case, we are assuming that output YT is equal to IT. That means current is taken as the output of the system. I have mentioned it as equation 3. I am having some reason, because state variable equations are generally given equation number 1 and equation number 2, and output equation actually is given as number 3. Okay, so in this case, first case, I am taking current as the output. Some in the second case, maybe I will take VCT as the output. Third case, I may take VRT as the output. Okay, so there are different state variable representation possible. So first case, we are going to develop this state variable model. We are taking output as current. So current is being taken as the output element or output parameter. So what are the defined states or what are the different state variables? State variable का state होता है. Okay, so if we are saying that one state variable is IT, okay, at every instant of time, how much is the value of IT? That will be the state of the first state variable IT. Okay, so we will be having an equation of IT. So this IT equation in a series RLC circuit, maybe it will be e raised to minus 3t or something. So state variable equation we can find out. So whenever we are solving the state variable model, we will be able to find out what are the equations of the state variables in time domain form. That is, IT is equal to, suppose, e raised to minus 3t or something, or maybe it's a complex equation. VCT may be the same thing, 4 by 3 maybe 4 by 3 e raised to minus 2t plus 7 by t e raised to minus 5t, that kind of thing. And there you have to substitute the value of t as different times, 0, 0.1, 0.2 or 0, 1, 3, 4 seconds, and you can find different at different time instant what are the amplitudes of the state variable. So state is different, state variable is different. State variable is IT. It will be having an equation. In that equation, substitute different value of t. You are going to get different states for the given state variable. So first case, we are assuming IT and VCT, they are the two states. Samely VRT, that is whatever is the voltage across the resistor, VLT, whatever is the voltage across the inductor, VCT, it is already being assumed as a state variable. So there can be maximum 4 state variables in this system. One is IT, one is VCT, another is VLT, another is VRT. So for different state variables, the state variable representation will be different. I am telling you repeatedly. But for the first case, we are assuming IT and VCT, they are the state variables. So let us see how to find out the state variable model when IT and VCT, they are taken as a state variable 1 and state variable 2. Okay, so which one is taken as 1, which one is taken as 2, that is very important. So we are taking IT as state variable 1 and VCT, that is the capacitive voltage, as state variable 2. Write the KVL equation. So whenever we are doing a modeling, we should know what are the equations that is defining the system model. So xt input, you can see this system. So xt, whatever is the input, that is equal to resistive voltage plus inductive voltage plus capacitive voltage. Now how is inductive voltage written? It is L into dit dt. We know this equation, that is input is equal to, we are writing the KVL equation, xt is equal to L dit dt plus R into IT plus VCT. Okay, so whatever input voltage we are giving, that is being getting divided into three parts. This is a simple voltage divider rule. So first is inductive voltage L dit dt, second is resistive voltage RIT, and third one is capacitive voltage VCT. Now from here we have to find out what is I dot T. What is the standard representation of state variable is x dot t is equal to axt plus but. This you have to remember. What is that? X dot t is equal to axt plus but. What is a and what is b? I will tell you later. So first we have written xt is equal to L dit dt. X is the input to the system. From here we have to find out the differential equation for the first state variable. And samely we have to find the differential equation of the second state variable from another equation. So what are our state variables? One is IT, another is VCT. That means we have to find out two equations in IC or I dot T, that is dit dt, and Vc dot T, that is dVct dt, that we are supposed to find out. So just see here, here I dot T is already existing. So xt is equal to L dit dt. Dit dt is nothing but I dot T plus RIT plus VCT. And dit dt equation I'm trying to find out, that means this RIT part and VC part has to be taken in the other side. So in the next line only I am writing dit dt separately. What is dit dt? It is nothing but I dot T, that is the first derivative of IT. IT is the circuit current, which is the first state variable. So what is the equation? We started with KVL, and from the KVL we are trying to find out what is the differentiation of the first state variable. So dit dt or I dot T we are finding out. So if you are taking the R in the other side, it will become minus RIT and divided by this L. So dit dt, if you just rearrange a little bit, you will be finding dit dt is equal to minus R by L into IT minus 1 by L into VCT. So this VCT will go in the other side and it will become minus, and then this L will be dividing this VCT. So first is minus R by L IT minus 1 by L VCT plus 1 by L XT. XT is the input. So what we are supposed to represent is, we are supposed to represent the, now listen this carefully, we are supposed to represent this differentiation of first state variable, that is dit dt or I dot T, that should be in terms of IT, which is the first state variable, VCT, which is the second state variable, and input, which is xt. So this is actually the state variable model. All the differentiation of state variables should be equal to a function of first state variable, second state variable, and input. What is the first state variable? IT. What is the second state variable? VCT. What is the input? XT. So we are supposed to find out that first state variable differentiation, that is dit dt I dot T is equal to minus R by L of IT, first state variable. R by L is system constant, R value, L value, C value, XT will all be given to you. And xt should be known. So initial discussion we have seen that we can find states only if we know what is the input at every time instant. So xt will be given to us. What is the type of xt, what is its amplitude at every instant, we know. So I dot T is equal to minus R by L IT minus 1 by L VCT. IT is the first state variable, VCT is the second state variable, and 1 by L of xt. That means first state variable differential equation, that is dit dt or I dot T, is a function of first state variable, second state variable, and input. This is the representation. So any system given, if you are asked find out its state variable representation, So differential equation of, or first order differential equation of the first state variable should be equal to some coefficient of state variable 1 plus some coefficient of second state variable plus some coefficient of input. Sometime this coefficient might be 0. Okay, sometime it is possible that I dot t equation VCT will not be there. It is possible. So in that case, we will write 0 into VCT. Okay, but other than this three, anything should not be there. So first state variable differential equation is equal to coefficient of first state variable. Here I dot t is not there. It is simple it. Okay, here it is I dot t in the left side. Right side it is simple it, simple vct, and simple xt. There should not be any other component. So we have to rearrange the terms in such a way that it appears this way. So this equation I am calling as equation 1. Second equation VCT. Why have I taken VCT? Because VCT is our second state variable and we want equation of VC dot. VCT is equal to 1 by c integration of it dt. Standard formula, we know it very well. What is VC dot t? It is 1 by c of it. And what is it? It is the first state variable. So you see that this is the equation number 2, and this VC dot t we are writing as 1 by c it plus 0 VCT plus 0 xt. Why am I writing this? I am trying to show that the differential equation of the second state variable. What is the second state variable? VCT. Differential equation of that is dVCT dt or VC dot t. That means first order differentiation of the second state variable VCT, that is equal to VC dot t, or dVCT dt is equal to some component of first state variable, that means 1 by c of it, plus some coefficient of second state variable, that is 0 into VCT, plus some coefficient of input. Now in this case, as VC dot t is having only it in it, so coefficient of VC and coefficient of x will become 0. So this is the second equation. Initially we have the third equation, yt is equal to it, that we have seen initially, because I have mentioned in this numerical that output you can take as the current. So that's why I am already having the third equation with us, yt is equal to it. First and second equation we have written from our expertise in the domain of electrical equation and electrical network. So out of that we have written two equations, that is I dot t is equal to minus r by l of it minus 1 by l of VCT plus 1 by l of xt. What is xt we don't know, okay, but we can write it like this. Second equation we have written VC dot t is equal to 1 by c it. Same equation I have written as 1 by c it plus 0 VCT plus 0 xt. That means first state variable differentiation is equal to some coefficient of first state variable plus some coefficient of second state variable plus some coefficient of input. Second state variable differential equation is equal to some coefficient of first state variable plus some coefficient of second state variable plus some coefficient of input. Now this equation 1, 2 we will write in terms of matrix. How to write that? So this is called as a x dot t, or this is called as, what is x dot, this is called as q dot t. Okay, what is q? Q is nothing but the matrix of state variables. So here in this case there are two state variables. So this is very important thing. This is called as a state variable matrix. And what is the dimension? There are two state variables. Dimension of the state variable matrix will be n cross 1, where n will be the number of state variables. And state variable number is directly proportional to the number of energy storing element in the circuit. In the circuit there are two energy storing element. That means there are two state variables. That means the state variable matrix will be having dimension of 2 cross 1. Okay, this is always there. If there are 4 state variables, in this case this state variable matrix will be having 4 cross 1. Okay, so in this left side this is called as q dot t, or differentiation of state variable matrix. So q dot t is nothing but I dot t and vc dot t. Now let us see what is the I dot t equation. So I now represent the first and second equation in a matrix form. So first equation I dot t you will be finding from the top row. What is the first equation? I dot t is equal to minus r by l into it. So if you see, if you multiply this A matrix or state matrix with the state variable matrix, then you are going to get the first row or I dot t equation. So I dot t is equal to minus r by l into it minus 1 by l into VCT plus 1 by L into xt. I will tell you how to find I dot t from the state variable representation. So state variable representation, left side, this is the differentiation or first order differentiation of state variables. So this is the standard form of state variable representation. So I dot t and bc dot t, they're in the left side. Right side, it is state matrix, that is A matrix, which is called, and dimension of this thing is 2 by 2. Generally it is called n by n, where n is the number of state variables. And here it and vct, they are the state variables, and this B matrix is called as an input matrix. You are finding that in I dot t, xt is having some bearing with coefficient of 1 by L. Okay, but in a vct or vc dot t, there is no xt, because xt is 0. So that's why the B matrix will be 1 by L and 0. So how to find this I dot t from the equation? So this equation I dot t is equal to minus r by L of it minus 1 by L vct plus 1 by L xt. That we want to represent in the matrix form with another equation vc dot t. So these two equations together, when we are representing, this is the most important equation, which is called as state variable model of the system. So how to do it? I dot t is equal to minus r by L into it minus 1 by L into vct plus 1 by L into xt. Okay, and samely vc dot t. So vc dot t is actually 1 by c into it, but we have represented in 1 by c into it plus 0 into vct plus 0 into xt, because we cannot ignore the presence of this vc and xt in the state variable model. Okay, so their coefficient we have to write as 0 0, because vc dot t is only 1 upon c of it. So how to write vc dot t? Vc dot t is nothing but 1 upon c into it. So this first row element gets multiplied with the first column element. So ic into it, or sorry, 1 by c into it. So vc dot t is equal to 1 by c into it plus 0 into vct plus 0 into xt. So whatever are the coefficients of it, I dot t, it comes in the first row, first column. Whatever is the coefficient of vct, that comes in the first row, second column. In the second equation, whatever is the equation of it is the first state variable, that is 1 by c. That 1 by c comes in the first column, but in the second row. And whatever is the coefficient of vct in the vc dot t equation, that comes as the second row, second column element as 0. Okay, so this is called as a state variable representation for the given system, if it and vct are taken as the state variables. And at the same time, you can write down the equation of yt. So yt, I have told you that you can take yt. So generally, out of the two state variables, I can take one as the output equation. So it and vct, any of these two can be, generally they are taken as a state variable output. Okay, somebody wants to say, sir, I want to take VLT or inductive voltage as the output equation. That also can be accommodated in this YT equation, but we will see that tomorrow. So first case, YT is equal to IT, because I have told you that take IT as a output equation. So YT is equal to IT. That means YT is equal to IT plus 0 of VCT plus 0 of XT. So these two I am just writing because YT also will be in the same form. So now how will you write this equation? YT is equal to IT. So just see that there is coming a C matrix. So YT is equal to 1 0 of IT VCT. What is meant by that? YT is equal to 1 into IT plus 0 into VCT plus 0 into XT. So this equation YT is equal to IT. First I have modified it in the terms of all the state variables and the input. Because if you see I dot t equation, there is state variable 1, there is state variable 2, and there is input. If you see second state variable dot, that is vc dot, there is also state variable 1, state variable 2, and the input. Samely, yt also should be represented as first state variable, that is it. What is the coefficient? Coefficient is 1. Second state variable vct, what is the coefficient? 0, and the input. So this is 0 of xt. Now this first matrix, this is having dimension of 2 by 2. This is called a state matrix. It is called matrix A. Second matrix, which is connected to the input, this is having dimension of 2 cross 1. Okay, 2 cross 1 means 2 are the state variables. So this will be having dimension of n cross 1. Why 2 cross 1? Because there are 2 state variables. That's why there are 2 rows and there is only one input. Okay, that's why it is called as 2 cross 1. If there were 2 inputs, x1t, x2t, then this also would have been 2 cross 2. What is yt? Yt is equal to 1 cross 2, that is one row and two columns. Why two columns? Because there are two state variables. Okay, so very simple understanding of matrices are required. So this is 1 cross 2 plus this D matrix is called as a direct transmission matrix. This is generally having, as there is one input and one output, this is having dimension of 1 cross 1. So final time I'm telling you, I dot t and Vc dot t, these are the state variable differentiations, is equal to minus r by L, minus 1 by L, 1 by C and 0. This is the most important matrix in state variable representation. This is called as A matrix, or it is called as a state matrix. What is IT and VCT? This is the state variables. So there are two state variables, the IT and VCT. And then there is B matrix. So B matrix is nothing but the bearing of inputs, okay, in the I dot t and Vc dot t. So for the first equation I dot t, we are finding it is 1 by L of xt. That's why this coefficient has come as 1 by L. But in the Vc dot t equation, we found there is no bearing of xt, because Vc dot equation there was no xt. That's why the coefficient is 0. And finally, there comes C and D matrix. C matrix is called as output matrix. Dimension of this thing is 1 cross n. 1 is nothing but the number of outputs. I told you that this can take care of multi-input, multi-output system. So if there are two outputs in the system possible, in that case, C matrix also will be 2 cross 2. So here 1 cross 2, what is 1? 1 is nothing but number of outputs. In this case, I have told you there is only one output variable. That's why this is 1 cross 2. And what is 2? 2 is nothing but number of state variables. That means one output is actually relating two state variables. That's why C matrix is 1 cross 2. And what is D matrix? D matrix is 1 cross 1 because there is one input and one output. So this is the first numerical, which is very easily explaining. Mainly there are three equations, that is I dot t, Vc dot t, those we have combined together and we have got A and B matrix, and there is only one output given, so you only have to assume, if it is not given in the exam, any output you can assume, and you can write down YT equation accordingly. Now let us see some modification. So what they are writing is the same circuit or the system, which is a second order system with assuming different state variables, okay, will generate different ABCD. So somebody wants to say that, sir, I want to take inductive voltage as a state variable. In that case, your A matrix, B matrix, C matrix, D matrix coefficients will be different, and you can see that all the elements in the ABCD matrix, okay, they are nothing but the circuit elements. So minus R by L, minus 1 by L, 1 by C, 1, 0, all these are actually circuit elements. So depending on whatever system parameters are given to us, circuit parameters given to us, we should be getting what is ABCD matrix. And for further processing, it is used. And it is given I dot T and Vc dot T. What for they are used? You have done solution of differential equation. We can find out the solution for this differential equation also. So in the previous case, you have found out I dot t and Vc dot t. If you are finding the solution of this state variable, you will be finding an equation of IT and equation of VCT in time domain. So IT equation you will find and VC equation you will find. But if I ask you the same thing to find out from the circuit, you have to do a long mathematics and all. You transfer it into Laplace domain, then take inverse Laplace and all. But in this case, if I ask you find what is the equation of IT, that means what is the equation of circuit current in terms of RLC, what is the equation of capacitive voltage in terms of RLC, and find capacitive voltage at different instant of time. So find states of VCT, find states of IT. All these things are possible, and all these things will be done by computer. So that computer will be solving all these things for you. Only what you have to input in case of circuit is A matrix, B matrix, C matrix, and D matrix. Then you have to give some different command code. It is there. So there are many code syntax and all these things for state variable analysis, and you will be getting what are the different states, what is the graph of IT, what is the graph of VCT. All these things you will be doing in the lab. Okay, so as a part of the lab, you will be doing it. So I'm telling you now, the same system, RLC series system, if somebody else is assuming different state variables, they are going to get different ABCD matrix. So same system, same circuit, but just by different assumptions, we will be getting different output. Now let's assume for all RLC circuits, output parameters is now a VCT. So in the previous case, the same numerical, I'm not saying previous numerical, because only this numerical we are going to do today. And in the same numerical, in the next case, this is the next case we are going to see, YT is equal to VCT you assume. Previous case you have assumed YT is equal to IT. Okay, in that case it was IT plus 0 VCT plus 0 XT. But now in this case I am asking you to assume capacitive voltage as the output parameter. That means YT is equal to VCT. Okay, so I dot T and VC dot T equation, they remains the same. There is no change in the equation 1 and equation 2 in the previous page. Okay, that means the top IC dot VC dot, that part will remain same. A matrix B matrix will remain same. What will change? C matrix will change, because in this case I am asking you to take YT is equal to VCT. That means 0 of IT, 1 of VCT and 0 of XT. So if you are representing now the overall system, so this is actually the overall system state variable representation. What all it includes I dot T, VC dot T, A matrix, state variable matrix. So here there are two state variables. This is called A matrix, which is called as state matrix. This is called B matrix, which is called as input matrix. So state matrix dimension is n cross n. In this case, n number of state variables are equal to 2. So A matrix will be having dimension 2 cross 2. B matrix will be having dimension 2 cross 1 or n cross 1, where 1 is the number of input. So in this case only one input we have mentioned, if you remember the circuit. That's why dimension of B matrix will be n cross 1 or 2 cross 1. But Y matrix you see here. In this case YT is equal to VCT. So if you multiply this, 0 into IT plus 1 into VCT. Okay, that means YT is equal to VCT plus 0 into XT. So actually we are writing YT as VCT is equal to 0 IT plus 1 VCT plus 0 XT. So this thing, YT equation can be written in this output equation form. So the top equation is called as system equation and the bottom equation is called as output equation. So the whole state variable representation changes. So state variable representation means actually we are supposed to find out four matrices: A, B, C and D. That's all. And most of the cases D matrix will not be there. What is D matrix? It is called direct transmission matrix. I told you while I was teaching you the signal flow graph or block reduction, that is from input directly there is coming a path to the output. Okay, so that path is having a coefficient which is called as D. And just now very shortly I will show you what is the block representation of state variable representation. There you will be able to understand what is actually the significance of D matrix. But here you can see previous case IT and VCT were the state variables. In this case also IT and VCT are the state variables, but previous case output was equal to the first state variable, that is IT, and hence C matrix was 1 0. In this case YT is equal to the second state variable, that is VCT, hence C matrix has become 0 1. So the solution of first state variable system matrix and solution of second state variable system matrix, they might be different. Okay, because now C matrix has changed. So in previous case with YT is equal to IT, C matrix was 1 0, but now YT is equal to VCT, C matrix has become 0 1. Okay, A, B, D matrix, they are unchanged. So just a conclusion I'm giving you after we have done some two different modeling or two different state variable representation for the same system. Now I have given you some explanation. So A matrix is called as state matrix. 2 cross 2, it is actually n cross n, where n is the number of state. And number of state depends on number of energy storing element in the system. So there are two state variables is equal to two energy storing element L and C. That's why A matrix or state matrix. Okay, sometimes it is called a system matrix also. So state matrix, A matrix is called a state matrix. Most important part of state variable representation. This is having dimension 2 by 2. B matrix is called as input matrix, which is 2 cross 1, which is actually n cross 1 or n cross m, you can say. N is the number of state variables and m is the number of inputs. So in this case, number of state variable is 2, number of input is equal to 1. That's why B matrix is having dimension of 2 cross 1. So 2 is number of state variable and 1 is the number of input. C matrix is called as output matrix, and dimension of C matrix is equal to, it is given in the next page, dimension of C matrix is given by 1 cross 2. Okay, what is 1? Actually it is called P cross N. Okay, what is P? P is the number of output and N is the number of state variables. So in this case there is only one output, Y1T or YT. Okay, that's why it is called as 1 cross 2. That is the dimension of C matrix. That means 1 row 2 columns, because it is 1 0 0 1, whatever you say, but the dimension of C matrix is 1 cross 2. So where 1 is the number of output and 2 is the number of state variables. So what is the dimension of A matrix, state matrix? It is n cross n. We have found. What is the dimension of B matrix, which is called as input matrix? It is n cross P. or 2 cross 1 here. Sorry, n cross m. I'm sorry, n cross m. M is the number of inputs. So 2 cross 1. And what is C matrix? Output matrix. The dimension is P cross n, where n is the number of state variables and P is the number of output. D matrix is called as direct transmission matrix. It is generally given by M cross P, that is number of inputs cross number of output. As in this case, number of input and output both are 1 and 1. In this case, the D matrix or direct transmission matrix is having dimension as 1. Okay, and there is no component as direct transmission because Y matrix is not having any bearing. There is output is not having any direct bearing on input. Not direct. It is bearing is there, but not direct. Okay, so what is direct bearing? So now below I have shown you a diagram which is called as block representation of ABCD matrices or state variable matrix positions. Okay, so in an overall system, okay, xt is the input and yt is the output, where all these matrices are existing. So B matrix is called as the input matrix. It is called as n cross m. If there is only one input, then it will be n cross 1. Okay, so B matrix input given to the system. So for this system, we are having only one input and yt is one output. So D matrix is very clearly shown here. D matrix is nothing but a direct transmission matrix. So you are finding that from xt, this link is directly going to the output. So this is the block representation. Whatever fundamentals of block representation you understood previously, all the things is standing here. Okay, so this is a summing point at the output side. This is a summing point at the input side. B matrix is the input matrix. I told you before, and here this is the central part. Central part is actually the heart of the overall system. So qt and q dot t. Initially, I had mentioned it xt x dot t. Sorry, there's a change. So qt and q dot t. Okay, xt is taken as the input. That's why I have changed it to qt and q dot t. So qt is actually the state variables. And what is the dimension of qt? It is 2 cross 1. So it is 2 row and 1 column. And q dot t, it is nothing but the differentiation of the state variable. So q dot t equation we are writing in terms of qt and xt. So you are finding that this xt is coming here, getting multiplied with bt. So this is b into xt. Then there is q dot t. And then there is a matrix is coming. So here at this summing point, you are finding this is a of qt. So here a of qt is coming and here b of xt is coming. So what you are finding is q dot t is equal to a of qt plus b of xt. Okay, and here is the C matrix. C matrix is actually yt is equal to c of something plus d. So yt is equal to c of qt. So from here, if you are saying yt is equal to c of qt plus d of xt. So whatever is the representation of state variable, what is that? Q dot t is equal to aqt plus bxt. So that we are finding here. So this is q dot t, differentiation of state variables. That is qt is coming from here and a. And what is the dimension of a matrix? It is 2 by 2 or n cross n. That means number of state variables. It's a square matrix. A matrix always is a square matrix, which is called as state matrix. So q dot t, this is actually the system model q dot t. That is how the state variables are changing with respect to time. That is given by the q dot t. So q dot t dimension is same as qt dimension. Here qt dimension is 2 cross 1. So q dot t dimension also will be 2 cross 1. Okay. So q dot t is equal to aqt plus bxt. This is something we are finding. This is the first line of equation of state variables. And yt is equal to cqt plus dxt. So this is what we are finding. These two equations, that is q dot t equation and yt equation together, they are actually called as a two ways for two different cases. And now I am giving you what is called as now I have given you what is called as the block representation of state variable representation. So with this basic, we will stop today. More we will see tomorrow.